Holy smokes. What up, yo, from the 403 to the HA. Z, Mr. Nelson here. I can't begin to tell you how many videos I have made. I've been up here, I'm having a conversation, you know, we're bonding, I'm spitting out really funny jokes, all this stuff. I finish it, I'm like, okay, that was a good video, only to find out that either my phone has just shut the video off because I'm out of memory, or the battery dies. Like, that just happened. So I just gave you like the best video I've ever pumped out in my life, and now we have nothing to show for it. So here comes sloppy seconds. Not going to be the best, but we're going to do our best. I just came back from, so we have an arena next door, beautiful arena, and they just had, like, they're taking the ice out in a couple weeks, and they just had the little ones do their little figure skating demonstration. So I went and watched, and they had little sharky things and little shells on their back and coconut shells, and they were doing it all to the Moana soundtrack, which I love. So that was super cute. Super cute. Which was actually a really nice break from all this coronavirus hysteria. It is March 13th, the day before spring break, and I don't even know if we're gonna come back from spring break. Everyone's really freaking out right now, and I'm taking advantage of the cheap flights to hopefully go to Maui for a surf, so we'll see. Let's see. Might have to quarantine myself for 2 years afterwards, but hashtag worth it. Let's talk about surface area and volume of spheres, okay? Because last semester I finished videos on cylinders and prisms, as well as cones and square-based pyramids. Spheres are really easy. That might be one of the reasons I left them out, or just didn't prioritize them. But what is a sphere? It's a pretentious, fancy word for a ball. It's not pretentious, I'm kidding. It's a ball, and this is a circle, and then I can kind of give my little balloon thing to make that's the shiny spot. That was what makes it a ball. And the beautiful thing about working with spheres is there's only one variable we ever have to worry about, and that is the radius. Okay, so in this video I'm going to talk about calculating volume and surface area of spheres and of hemispheres, which are half spheres. And then I might actually talk also about solving for the radius when they give you the surface area or the volume, because it's a one variable algebra. My dog looks so depressed and just not into this, because she was like, oh, I thought we're done, right? We're done. And I was like, yeah, we're done. And now she's sitting here moping. This is my 50th video, so I'm taking liberties and talking a little bit more. This is Jessie. Very unimpressed, eh, Jess? Very unimpressed. Sued my baby. So here are the formulas. Volume is, let's do the area. Area is 4 pi r squared. 4 times pi times r squared. It's just the r that we're squaring, not the whole thing, okay? We don't write it like that, but it's just the r that gets squared. And then for volume, it is 4 over 3 pi r cubed. 4 over 3 times pi times r cubed. It's only the r that's getting cubed, okay? But they don't write it like that. So let's just jump right in and solve for area and volume. And I give my students all a formula sheet. I'm not sure if you can see this for this unit. I don't expect them to memorize formulas. I don't, because I don't remember them, and all I have to do is jump on the internet and it's right there. But we have to learn how to use them. So the formula sheet I found, which is the best one I've found so far, it has all of our shapes here. I still have some nail polish from a while ago. I have the shapes here. My surface area column has all the formulas for the surface area, where it breaks it into the parts, and then it has the total surface area. SA is the total surface area, and then the little parts that are made up of it. And then I have the volume formulas down here. So all I have to do is identify what shape I'm dealing with and what it wants me to calculate, area or volume, and then I just find that spot. It's very, very easy. I'm an engineer, and We love our formulas. We don't care about the theory. We don't care about how you derive the formula. Just give us the darn formula and let us use it. Or the equation. Give us the equation. We just want to plug and chug. We don't like getting caught up in detail. So I'm all about this unit because I think it's very straightforward. You just have to trust the formula. Just trust the formula. It's not going to lead you astray, but you have to use it properly, and that's what we're going to talk about. I'm talking too much, so let's just do some math. So let's imagine that I gave this as a radius of 5 centimeters. So the first thing I'm going to do is I'm going to calculate the area. And my area, I know, is just equal to 4 times pi, and hopefully by now you recognize that pi we can just assume is 3.14. I think it goes like 159, blah, blah, blah. But 1529, I don't know. I don't want, it's 3.14. That's good enough, but we have a button in our calculators for pi, which is more accurate if we use it. So 4 times pi times r squared, and r squared is 5 centimeters squared. I'm just squaring that 5 centimeters. So if I had to put this into my calculator, I'm hoping you're using a graphing calculator like my old school TI-83. I don't know if they've advanced since then. I'm going to type it into my calculator exactly like this. I'm going to write 4. I'm going to press 4, and then I'm going to press the button for pi. And then I'm going to open my bracket. I'm going to write 5, and then I'm going to square that 5. Because I'm not trying to square this stuff. And that would, for me, once I put it into my calculator, 4 pi 5 squared, 314.2. And the units were centimeters, and we squared the centimeter. So it's going to be centimeters squared. It's a 2-dimensional measurement area, so it should be squared. Done. That's it. We've just calculated area. Super easy. We don't have to think that much with spheres. Volume. Now I know that students get tripped up with this 4/3 when they're putting it in the calculator, so we'll talk about that. Volume is 4/3 times pi times 5 centimeters cubed, okay? In my calculator, this is how I would do it. I'm going to make a bracket. I'm going to do 4 divided by 3 in that bracket. And then beside that, I'm going to write pi, and then I'm going to open up another bracket and do 5. Now, I have to go into math, into my calculator, into like my list to find the cube, but I can just use the up arrow. On my calculator, it's right there, just an up-looking arrow. Hope you can see that. 5 to the power 3. And I would write 3, but it's going to know it's to the power 3. This means 5 cubed. But that's how I would type it in my calculator. I'm just showing you how I do it in my calculator. And then this would be nice enough to pump out $523.6 centimeters. Now it's cubed here. The centimeters cubed, so it's going to be centimeters cubed. It's volume. It's a 3-dimensional unit. I'm checking that we're still filming. Holy crap, could it be? We're still filming. What a miracle. Coronavirus miracle. Okay. That's it. So if this is really hard for you, you always get the wrong answer, and you just can't seem to get it, I would just break it into its parts, okay? The first thing I would do is I would multiply 4 by pi and then divide it by 3. I would calculate what this is, and then I would do 5 cubed, or 5 times 5 times 5, and I would figure what that is. It's 125. And then I would just multiply 125 with whatever answer I got here, okay? I would just break it up into the little parts and record the numbers, because, you know, if you don't got the calculator skills, you need to practice it, but you need to also get the right answer. So do what works for you, or ask an adult. I'm sure your teacher, your handsome teacher like Mr. Nelson, is more than happy to help you. That's the baseline, okay? All we're going to do in any problem when we're calculating the area or the volume of a perfect sphere is we're just going to replace the 5 with whatever number we have. So the second situation we need to talk about with spheres is the situation where we start dealing with a sphere cut in half, or a hemisphere. Hemi means half. Hemisphere. So that would look something like Come on. Decent. Decent. I just can't help myself. There we go. Decent. Oh. Decent. Not decent. Mint. Okay. Here's a hemisphere. And this hemisphere is going to have a radius that they're going to give us. And let's say that this radius is now 10 meters. So this is a big dome, a big old dome, a big dome tent. Something you'd see at Coachella. Never been, but I hear it's great. A little bit better than Fire Festival, from what I've heard. So how do we calculate the surface area of this thing? Well, it's a half sphere, so I know that the outer shell, I can calculate the outer total, the total outer area of my ball, and then I can just divide it in two, because I have half that outer area now. However, by cutting it in half, I've also exposed this base here, which is a circle, and we know how to calculate the area of a circle. So I'm going to have to calculate the area of my shell, I'll call it, the area of my outside of my hemisphere, and it's just going to be 1/2 of times 1/2 of my 4 pi r squared, right? Because my area, I should put these up here, area of a sphere is 4 pi r squared. And listen, if they ever give you diameter, if they ever give you the whole distance, just divide it in 2. But if you choose that, if you like working with diameter, figure it out. You got formulas for there. I'm going to teach you radius. So if they ever give you diameter, just divide it in 2. So you're dealing with radius. I'm not angry. That seems angry. Okay. So what happens when I do a 1/2 times a 4? Well, I can rewrite the area of the shell is just going to be 2 pi r squared. Now I could have calculated 4 pi r squared and then divided it by 2 at the end. Or I could just know that it's 2 pi, well, 1/2 of 4 is 2. So that's what the area of the shell is going to be. And then I'm going to have the area of my base, or my circle of my base. This blue is just, you're getting a lot of mileage, bro, that you don't really deserve. I'm going to shake it. Shake it, shake it, shake it, shake it, shake it, shake it, shake it. Hopefully it works. Okay, area of the base is a circle, and the area of a circle is pi r squared. So my total area, which I'll call surface area, my total area, which includes the base that's now exposed and my half sphere, is going to be area of my shell plus area of my base. And I could calculate the area of my shell, and I'll do that. So it's 2, and in my calculator I'd just write 2 pi, and then I'd open bracket 10 squared. And obviously, my high school teachers are yelling at me right now about not including my units, so there we go. Okay, but in your calculator, you would just write it like this. And we would get, for the area of the shell, 2 pi, 10 squared, we'd get 628.3. And what are the units? Meters, and it's squared because it's area. And then the area of the base, well, if I notice, it's going to be half this, because this is 2 pi r squared, and this is just 1 pi r squared. But let's just pump it in. 10 meters squared is equal to 314.2 meters squared. Now all I have to do is add those two together. Now, I could have also recognized that surface area, if I wrote these out, is 2 pi r squared plus pi r squared. There's 2 pi r squares here, and then there's 1 pi r squared here. I can add those together, and I could actually get that my surface area is simply equal to 3 pi r squared. And that would give me the same answer that adding these two would do as well. But let's just add them up. Area is 628 for my shell, 0.3 meters cubed squared, plus 314.2 meters squared. And that gives me a total area of 942.5 meters squared. And then if I use this formula, I'll just type it in, 3 pi, open bracket, 10 squared. And I get the same answer, 942.5. Okay? I'm just showing you the two different ways we can calculate this, okay? There's a lot up here, but it's for a very simple thing. I have the area of the shell, which is 2 pi r squared, which I calculate here, the area of the base, which is pi r squared, and then I added the two together to get the total surface area of that shape. 942.5 meters squared. Okay. Now, there's one other situation which I'm actually going to get into more in my next video. But I do want to just touch on it briefly. I just did the volume, I just did the area. Let's finish with the volume. Volume, I know, is 4 over 3 pi r cubed. That was my formula. I'll put it up here. Okay. So, I have half a sphere, so you guessed it, I'm going to have to divide whatever volume I get here, I'm going to divide by 2. Right? Now, there's a lot of different ways I could notice this. I could notice that 4 over 3 divided by 2 is 4 over 6. Is that right? 4 over 3 divided by 2, yeah, it's times 1/2, yeah. Sorry. So that 4 over 3 divided by 2 is 4 over 6, and then I just go pi r cubed. That's one way of doing this, or this could be rewritten as 2 pi r cubed over 3, 2/3 pi r cubed, which I could rewrite as 2 over 3 pi r cubed. Okay, but I'm just going to do this because I have the one formula. I'm going to figure out what the total volume is here, and then I'm going to divide it by 2. And I'm just going to show you exactly how I would put it into my calculator if I can find my fancy schmancy black pen. I don't know how I lose these. Did I throw it out? I don't know how I do this all the time. Well, I do know how. I absolutely do know how. So in my calculator, I would do this. I'm going to open, because I want to calculate all of this, and then I want to divide all of this by 2. So I'm going to open one big bracket that's going to represent all of this. Now I'm going to do a bracket for my 4 divided by 3. Close that bracket. I'm going to type in pi, or I could just open another bracket and write 3.14. But if I just write pi, that means 4 over 3 times pi. And then I'm going to open a bracket for my radius, and I'm going to do 10 to the power of 3. Or if I have a button to do 10 cubed, I do that. Now I've closed this bracket, I've closed this bracket, now I have to close this bracket, and then I can divide all of that by 2. Or the button for division might be this, right? But I'm going to divide all of that by 2. All of this gets divided by 2, and so if I go ahead and do that, 4 over 3, wait, I just wrote that up there. Okay, I'm going to do this in my calculator now. So I get 4 over 3 pi 10 to the 3, and then I'm going to divide that by 2, and I get the volume is 2094.4. My units are meters, and I've cubed. My unit would be here. Okay, quit yelling at me. Mr. Filippetto, okay. We always need to show our units. Our units are always going to be whatever the measurement is that we're using. And when it's volume, it's going to be cubed. And if it's area, it's going to be squared. Okay? So that's how we did the volume. You're just plugging and chugging. It's a beautiful thing. Now, that was pretty straightforward, I think. We just took the half of a whole sphere. Now, what if this was actually like a silo? Like a real big storage container unit with, like a door down here, blah, blah, blah. How would I calculate the total outer surface area, not including where the silo meets the ground? Okay, I can do these several ways. This is called a composite object. It's made up of 2 shapes, a cylinder and a hemisphere. And so they'll have to specify. If they ask you for, finding the volume is pretty straightforward. The volume is always going to be, this would be the volume of a hemisphere, and then you add the volume of a cylinder, which we'll talk about in the next video. The total surface area, though, they have to specify what they want, right? So they would say, what's the total outer surface area of this shape? Well, in that case, this is not going to be exposed to the outside, right? This is a meeting point on the inside. So what you would see from the outside is this. And so we would have to calculate the surface area of our shell on the outside, a half sphere on the area, but we would ignore the base here because it's not exposed. It's not an outer surface area. And then we calculate the area of the side of a cylinder, which we have a formula for. It's just the circumference of the circle times its height. And then we would add the area of the base here, if they wanted us to include that. If they give you a shape and say, what's the area of this? So that's where we have to start thinking critically about, okay, well, what exactly are they asking for here? And we have to kind of just be a little detail oriented. But I'm going to do another video about all that stuff shortly. What I do want to talk about is, let's do a little bit of algebra. Ah, yes, sweet. So what if I know that the area of a sphere is 4 pi r squared. Now what if they said, you have a sphere, and the area of this sphere is, say it was 100 centimeters cubed. And they say, what is the radius of that sphere? And you would look here, you'd be like, okay, well, they've given me the sphere, so I have 100 here. I don't have to write, I'm not going to write the units right now. Okay, I am, fine. 100 centimeters cubed, then that's equal to 4 pi r squared. Now, they want to say, well, they're looking for the radius of that sphere. Of that beautiful, beautiful ball. Okay? So in order to determine the radius, I just have to do a little bit of algebra, which I'm hoping you're comfortable with at this point. 4 pi is a number. It's a number. I can absolutely know what that is. 4 pi is 12.566. So I could actually replace that with 12.566. But I'm not going to. I'm just going to leave it like that. I'm trying to isolate for radius. Now radius squared is being multiplied by 4 pi. What's the opposite of multiplying? Dividing. So I'm going to divide. What I do to one side of the equal sign, I have to do to the other. I'm going to divide both sides by 4 pi to cancel that. That becomes 1. Now I have 100 divided by 4 pi. Sorry, it should be centimeters squared there. I made that mistake a while ago. Over 4 pi is equal to the radius squared. Now I have to get rid of that squared. What is the opposite of squaring something? Taking its square root. So I'm going to take the square root of both sides now. In doing so, that cancels with that, leaving me with just the radius, but I have to take the square root of this side. And so I would do 100 divided by 4 pi, write that number down and take the square root of it. Or I would do square root, open bracket, 100 divided by, open bracket, 4 pi. When in doubt, bracket it up, baby. And I get 2.82. So my radius, now it's a one-dimensional thing, it's not squared anymore because it's radius. And we took the square root, when we take the square root of a square, it goes away, I get 2.82 centimeters. I'm feeling pretty good about that answer, but how can I check it to make sure? Well, I can plug it back into my formula here and make sure it spits out that. And that's what I'll do. Area of sphere is equal to 4 times pi times 2.82 centimeters squared. 4 pi 2.82 squared gives me 99.9, but that's because I rounded, so that means that I'm close enough. That is my radius. We can do the same thing with volume. Okay? So let's say they said the volume of your sphere is 400 centimeters cubed. And they say, what is the radius? Well, you say, okay, well, the volume of my sphere is 4 over 3 pi r cubed. And I'm going to now solve for r cubed, okay? And I can write that there. I'm going to replace the volume with 100, or with 400. I could have left the volume as a variable and replaced it with 400 later, but I think you guys like numbers better. So 4 over 3 pi r cubed. Okay. First thing, 4 over 3 pi is a number, okay? And I can calculate what that number is. I'm going to do the same thing. Now I can divide both sides by 4 over 3 pi, but I'm going to show you how to properly isolate 4r cubed. What I would do is, the first thing I would do is multiply both sides by 3. I have everything is being multiplied here, so that 3 is going to cancel with that 3. What I do to one side, I have to do to the other. And then I'm going to be left with 1200 on this side, 3 times 400, is equal to 4 pi r cubed now. Now I'm pretty much in a nice, happy place where I've seen this before. I'm going to divide both sides by 4 pi. And then I'm going to check to make sure that I'm still filming. Oh my goodness, yeah, this is a long one, so I can't lose this one. Now I have r cubed is equal to 1200 over 4 pi. What's the opposite of cubing something? It's taking its cube root. Now you're going to have to look in your calculator under math, and it's actually under math. There's a cube root button, and you can just click that and then write what you have. So the cube root's going to get rid of that, and it's going to get rid of all that, but I have to take the cube root of both sides. What I do to one side, I do to the other. So I have, not the square root, I have to take the cube root. And if I do that, 1200 divided by 4 pi is 4.57. So I get r is equal to 4.57, and it's centimeters. Okay? This is a long video. I'm going to leave it there, but you can imagine you get into situations where maybe they give you a half sphere, and they say, they give you the area, and you have to calculate the, say they give you the area and you have to calculate the radius. Well, you know that the radius is going to be equal to 4 pi r squared divided by 2 for this, for the shell, so it's going to be 2 pi r squared. And then we're going to do the area of the base plus pi r squared. And this is where using that 2 plus 1, 3 pi r squared is going to come in handy, because I can do some easy algebra with that. If they gave me the area, I could divide both sides by 3 pi, and then I get r squared is equal to my area over 3 pi, and then I just take the square root of both sides to calculate r. Okay? Volume is going to be the same thing. If you have if I had the volume, and I'm going to divide this by 2, if I just divided 4 over 3 by 2, I get 4 over 6 pi r cubed, and then I can just play with those numbers. Or if I went a step further, 2 pi r cubed over 3. So I multiply out the 3 first, divide it. It's very similar to this one, just different. Sorry if I talk too fast, but when you're making each video 5 friggin' times, you end up wanting to get through them. So that is spheres. I hope you've learned something. The last stop for this unit is composite objects. Composite objects just means objects that are made up of more than one shape. And if you learned how to deal with cones, prisms, cylinders, spheres, yada yada, and if you have a really good understanding with it, then the composite objects are easy, because you know what's going on there. You know what volumes to add together, you know what surface areas to leave out, all that stuff. I believe in you. Have a good spring break. Mr. Nelson loves you. Bye now.